this paper is identifying the ways in which AI companies use what is nominally framed as something you might think of as AI safety in some broad, capacious way to really respond to specific commercial incentives. And so we'll walk through how this works. And there are a couple of recent news articles from yesterday that I think are sort of alarming and relevant to this talk that I just want to identify briefly. So the first is that the EU is set to water down their landmark AI Act in response to pressure from big tech. And if you hadn't seen this special report from Reuters based on internal documents from Meta, estimating that upwards of 10% of their revenue comes from ads for essentially scam or fraudulent products. So this gives an idea of kind of the domain that we're working with, kind of the nature of these actors. And I think that's sort of important context to keep in mind here. And so what we do in the paper is build on Tim Wu's work to construct an anti-regulatory framework for thinking about AI. And so Wu identifies two types of mechanisms that we think are really relevant to thinking about how AI safety is used commercially. And so the first are what Wu calls, and we adopt, mechanisms of avoidance. And so these are mechanisms that decrease the probability of detection or to bypass a legal requirement of some sort. So examples might be, and I will get into these examples here in a moment, encryption technologies, federated learning, synthetic data generation, differential privacy. What these are sort of about, they sound good, right? Who doesn't want more privacy? Who doesn't want personally identifying information to be sort of anonymized and respected? Who doesn't want their data to be encrypted? And we'll see how these actually serve very kind of concrete commercial incentives. And so the second are mechanisms of change. And these are ways in which AI safety sort of mechanisms can be deployed to shape future regulatory arrangements to be more favorable to the companies themselves. So these could include things like open sourcing models, AI safety evaluations. This has become a really crucial example of this recently. Alignment techniques, voluntary standards, and the position of the companies themselves as the ultimate technical authority. And I think this is really important, that if you are an independent agency, like say an AI safety institute, educational institution, a nonprofit, your ability to conduct safety evaluations depends on your access to these proprietary closed-sourced models. And so this requires a certain degree of collaboration with the companies that are producing them. So that's a more kind of antagonistic relationship that is more typical of regulator and regulatee is thereby bypassed. So how do these avoidance mechanisms look in practice? And so we work through some of these examples in the paper. So one, encryption, right? The frame here, understandable enough, privacy, data sovereignty. But what that's really about is claiming that the data is non-personal. So second, federated learning, kind of a collective benefit by being able to distribute model training widely. And what that can do is really obscure data sourcing to bypass regulatory compliance requirements that arises from using particular kinds of data in different contexts. Third, synthetic data, be kind of a way of expanding data sets to reduce biases of various kinds. And this can also be used to essentially launder copyright obligations. Right, we've all seen examples of image generation models that if you say, okay, create an image of SpongeBob SquarePants, it won't do it. Create an image of an anthropomorphic talking sponge, it will have no problems doing that. Private set intersection is a form of secure collaboration. So we don't actually have sort of primary access to the underlying data. This is a way in which you can sort of farm out responsibility for the underlying data sets. And we look at this case of Google and MasterCard from 2018, where MasterCard provides Google with a set of sort of anonymized and encrypted transaction level records for Google to use in matching sort of their advertising data with MasterCard's transaction data. And so in this case, data that is nominally encrypted is really about serving this commercial objective. So So moving on, so to change mechanisms, and this is kind of what I think is kind of the real heart of the paper here. How the companies use AI safety mechanisms to proactively shape what sorts of regulations are even thinkable. So first, open source. Coming from the software engineering community, open source is generally considered to be kind of a self-evident good, right? The idea of being able to share things widely, collaboratively, creating a sort of inclusive, participatory scientific environment. And one way in which the EU AI Act was written was to exempt open source models from essentially all, not exactly all, more or less all requirements under that act. And then we'll see how that is further watered down going forward. And so there's a commercial choice to be made. So for example, if you were Meta and you don't have, say, a cloud computing business, you might have the commercial incentive to have more people use your model. You will open source it to increase adoption and minimize compliance costs, for the sake of argument. The second is to insist that the science of AI safety is itself nascent. And this is something that we just saw over and over and over again. The idea is that the newness of the science, and again, the science there also being crucially important to the argument, means that people need to slow down, that regulators can't move too fast. They can't move fast and break things because we just don't know enough about how these underlying systems work. We've done some work elsewhere to show that a large black box model with 1 trillion parameters, probably not going to understand how that works at any degree of sophistication anytime soon. It's a somewhat surprising argument to make. And on top of that, the primary kind of manifestation of the science of AI safety are these evaluations. And there's sort of a cycle here of funding research to build kind of scientific legitimacy, to then shape those standards. And if we've seen in both the California context, the recently approved SB 53, and then also in the European context and others as well, that companies are not necessarily required to use a single standard, as technology regulation at, say, the federal level in the United States often mandates, but instead they merely just have to state which standard they are using in an entire voluntary framework. So if they themselves create those safety standards, it doesn't take too much conspiratorial thinking to think that they're going to do that in such a way that minimizes their current and future costs of compliance. And so there's a way in which we can see just kind of self-evidently that there's a high degree of industry control over the evaluations ecosystems, right? Through funding AI safety institutes, sponsoring research grants, defining evaluation criteria, controlling model access, which then produces independent research that then in turn promotes the scientific legitimacy of this entire enterprise. So then at the end, what we're left with are sort of scientific validations of what is essentially the default path of corporate interest. So again, the nascent science arguments, we can claim that it's nascent. So one AI lab says the science of AI evaluations is nascent. That then requires that we defer regulation. So we shouldn't legislate too prescriptively or too early. Instead, what we do is we need to fund independent, or at least nominally independent, evaluation research that then allows us to maintain a kind of status quo, that voluntary frameworks remain sufficient. And for myself, coming from a background of previously working in and on finance, in the 2008 financial crisis was an example. One of the many ingredients of that was the idea that you choose which credit rating agency that you're going to use to rate your bonds, your CDOs. And so the commercial incentives there are obviously to be as permissive as possible. And so just recently, the state of California released a report from their Frontier Model Task Force. This was created after Governor Newsom's veto of 1047 last summer. And one of the claims in that report is that given the immaturity of the scientific foundations of modern AI, including a rigorous science of AI evaluation. But for, say, there are many academics and sort of people who've been in this field a long time who show that deep learning is never going to provide the kinds of scientific foundations of the safety requirements that you would like, for the simple reason that they're not humanly interpretable. And this connects with, I think, a longer, and this is one direction I think we might want to extend the project, of ways of thinking about the role of scientific expertise in areas where sort of commercial incentives are paramount. So just this year, close to $1 trillion of private capital expenditures building out AI infrastructure. So the book on the left, The Merchants of Doubt, is about the ways in which scientific expertise is leveraged by big tobacco and the fossil fuel industry to essentially cast doubt on what the obvious scientific consensus of the harms of these products are. And the second one is Michel Foucault's classic History of Madness, providing this kind of incredible look at the history of psychiatry and the birth of this category of unreason in the age of reason in the Enlightenment. And I got to thinking about this. So Henry Farrell, Alison Gopnik, and others had this great article from earlier in the summer that I highly recommend about AI systems as sociocultural technologies, right? So then if we think of these systems as being sociocultural technologies because they are trained on essentially the entirety of the digitized corpus that humanity has produced that's available somehow electronically, To what extent is this really sort of a natural science or even a computer science, although obviously computers are involved? What we're really looking at are sort of this amalgamation of all of these social and cultural categories. So then from that perspective, the science of AI safety or the science of AI evaluations then kind of has a much more kind of social scientific character. And one thing that one of the great contributions of Foucault's work in this context is to show in which the ways in which that the science of psychiatry becomes wedded to these broader sets of social interests. And so I think this can be a useful frame for thinking about this field of AI safety, particularly in this commercial context, which is not to sort of cast aspersions globally, but just the particular way it is utilized by those with large commercial interests in the furtherance of those commercial interests. So takeaways. The first, the technologies that are framed as safety measures in a kind of simple, straightforward, obvious way can function as these anti-regulatory mechanisms, a way of minimizing current and future compliance costs. Secondly, AI companies use both mechanisms of avoidance and change. That the nascent science argument delays regulation while the industry ultimately controls the research agenda. What sorts of statements are permitted to be considered scientific? I think this is really important, that what counts as science does not just sort of fall from the heavens fully formed, but is instead something that is the product of sort of circulating norms, discourses, and practices. And so forth, we look beyond the black box, that we want to examine the structures around AI development. And so principally, those are these, and I think this will be kind of an obvious conclusion to this for this audience, is that we shouldn't let scientific propriety obscure the obvious commercial incentives and power dynamics involved. And I think it's really important to center that as you're doing rigorous AI safety work, on the one hand, to also keep in mind this background context and make sure that the work that's being done in this way is not readily co-opted to serve commercial interests that may not align with collective flourishing and well-being. So with that, I look forward to your questions. Thank you very much.
Thank you for your talk. Gonna try to frame this question as best as I can. I've been thinking about consumer epistemology of knowledge and scientific development, and you're describing a process by which tech companies, through the evaluation frameworks and open source frameworks, encourage regulation by saying, trust the evaluation process. So I'm wondering if there's a systematic process that you've thought about, maybe through similar case studies of climate and tobacco, for either identifying, I don't know if it's propaganda or regulatory influence or consumer persuasion, but just like identifying this process for who has a stake in making a regulatory claim.
Right. This is a great question. And I think the first stumbling block, and this is something that our lab has sort of done the bulk of their energies on, is the fact that these systems don't have the kind of safety properties that you would want for something that is going to be a general purpose technology that is going to transform work, the economy, all of sort of maximalist claims that you can imagine. That you just don't have the safety properties that you would want, because there's no way to confirm that an AI system built with deep learning is going to conform to a sort of ex ante safety specification in the way that you would want. It just there's no technical way that I'm aware of for accomplishing that. And so trying to think about what safer foundations might look like. And so this is a little beyond my technical imagination, but things like probabilistic programming is seen as being something that's more kind of technically feasible. And so the first is having the sort of primary blue sky research in order to build those safer architectures. So this is why there have been those who have called for, say, moratoriums on AI development, because it is seen as being kind of inherently unsafe. So if you were just scaling everything infinitely, then the safety concerns are going to increase rather than decrease. And so you want to build the technical infrastructure on which you can then involve kind of a diverse group of stakeholders to then say, okay, what did safety actually look like? What do we want that to look like in a kind of more inclusive, robust way, as opposed to saying, well, here's kind of what we're willing to do from a commercial perspective, and we're willing to, we can make these really glossy, long PDF documents that seem to be very kind of objective and scientifically rigorous, but amount to saying, well, we're going to, maintain the status quo, and that's kind of the end of that. Good.
If there are any other questions, I think Brian can take them offline.